Okay, so let's say just the first, what will be the first term?
Over n plus 1. So the first term is 3 times 1 over 2. So that's 1.5.
What will be the 20th term?
That would be 3 to 6, 60 over 21 is 2 point. It'll be 60 over 21, which is 2.6 recurring, I think, so 6, 7.
Okay. And what will be the no, you could use a calculator. There's another way I want to show it. So if you have y equals 1 over n, so y equals 1 over n, so it's a bit like y equals 1 over x, except it doesn't have a negative part, because n starts from 1.
Yeah.
So it would go like 1, a half, a third, a quarter, and so on. Any idea what number it gets closer to as it gets bigger, like when n is 100, 1,000?
Closer to 0.
Yeah, so basically, as n tends towards infinity, 1 over n tends towards 0. And if I look at the graph of y equals 1 over x, so if we look at just the positive part, because it would be 1 over n, so it starts up, it starts at 1, so it starts here, and then gets closer and closer to 0. So let's say 3 over n, that could be written as 3 times 1 over n. And so no, let's go back for a second. So this one here, yeah, so what would be, if we were to put into a calculator, like the 500th term or something?
So 1 over 500, or?
No. So this one again, 3n, n plus 1.
This one is 1,500 over 501. My calculator kind of broke, so...
Oh,
sorry.
okay. Sorry, I thought you were using your calculator for this. So 3 times 500 over 501.
Yeah.
And as a decimal, it's 2.99. And so what number is it getting closer to?
Is it 3?
2.99. And why is that?
Because it's like the 500th term is really close to 3, but because it's increasing from 2, I don't know how to.
So there's another way to look at this. What if you were to divide the top and bottom by n? So what is 3n divided by n?
Just 3.
What is I'll write down here. Over n equals 3. What is n plus 1 over n? How could you make that? How could you write that?
Say 1 plus 1 over n.
1 plus 1 over n. So another way to write this, if you were to divide the top and bottom by n, would be 3 over 1 plus 1 over n. As n tends towards infinity, what will 1 over n tend toward?
Also infinity.
1 over n.
Oh, sorry, 0.
And so what you'll end up with is 3 over 1 plus 0, which is 3 over 1, which is 3. And so the trick for these is to divide the top and bottom by 0, by n. so that you get it in the form of something over n, which we know will tend towards 0.
Okay.
So there's a long explanation that they give, and I think that's just the simplest way. So using that, try this one.
So the limiting value, find the limiting value, consider the nth term as n equal to infinity. Because the nth term is 2n minus 1, 3n plus 2. 2/3. So that would be, if we divide everything by n, you'd get 2/3 minus minus 1 over n. I'm not sure how I could.
So I would just do the two separately. So like 2n, divide that by n, minus 1, divide that by n.
Okay, so 2n divided by n is 2.
Mm-hmm.
Minus 1 divided by n is just minus 1 over n.
Mm-hmm.
You could, so you'd have 2 minus 1 over n over 3n plus 2. And then we divide the denominator. So we have 3n divided by n is 3. 2 divided by n is just 2 over n.
Mm-hmm.
So that would be 2 minus 1 over n over 3 minus 2 over n.
Mm-hmm.
So you could say that the 1 over n kind of tends towards 0.
When does it tend towards 0?
When it's a positive.
When as n tends towards infinity.
Okay. Right. Okay. So
1 over n tends towards 0. Yeah. Okay. Go on.
N tends towards infinity. 1 over n tends towards 0. So you end up with 2/3. So n.
Hold on. What else would happen? What happened to the bottom as n tends towards infinity?
As n tends towards infinity, 2 over n
Mm-hmm.
tends towards 0 as well.
Yeah. And so what you would get is 2 minus 0 over 3 plus 0. And then simplify that.
Which is just 2/3.
Yeah. And so this is a kind of a prove that question. And so I'm just kind of making sure we've proven it.
Yeah.
Yeah, but the big idea is divide the top and bottom by n. And because they have plus or minus in between, you have to divide each of them by n. And then anything that is in the form of a over n will tend towards 0 as n tends towards infinity. So replace those with zeros. Like state that first, then replace them with zeros and then simplify. Any questions with that?
That's fine.
So divide numerator and denominator by n. They simplified it and so did we. As n tends towards infinity, 1 over n tends towards 0 and 2 over n tends towards 0. So they then, okay, I would have, they didn't even bother replacing the 1 over n with 0. But yeah, there you go. Okay. So these are the practice questions. So some of these are, okay, so let's try these. Is there anything there that looks worth doing? Let's do the very last one.
Okay. 2 minus 6n over 5 minus 2n is equal to, so we say 2 over n minus 6n over n. We could say that that equals to, I might write both of these as kind of, so I'll have two fractions, but I'll simplify it in the next step. So 2 over n minus 6n over n is the numerator.
Mm-hmm.
And denominator would be 5 over n minus 2n over n, which equals to 2 over n minus 6.
Mm-hmm.
So 5 over n minus 2. So as n tends towards infinity, 2 over n tends towards 0. As n tends towards infinity, 5 over n tends towards 0. So you have basically 0 minus 6 over 0 minus 2, which is minus 6 over minus 2, which is 3.
That's it. Any questions there?
I think I got that now.
Okay, and so eventually you can just look at the question and you'll know what the answer is, but there's also the prove that questions, and so you have to do this for other ones. And the way I did the first one and the way we saw in the mark scheme as well, you don't have to say as n tends towards infinity twice. You can just say as n tends towards infinity, 2 over n tends towards 0, and 5 over n tends towards 0.
Okay.
But this is a little thing. So let's go back. So this is kind of a reminder for last week. How would you do question 2?
Nth term is 4n minus 1, 2n minus 5. Work out the position of the term on the term that has a value of 2.36. So basically, 4n minus 1 over 2n minus 5 equals 2.36.
Mm-hmm.
So 4 minus 1 equals 2.36 times 2n minus 5. So 4n minus 1 equals 4.72 n minus 0.8. I think it will be 13.8 minus 13.8. So that is, so we have 4n minus 1 equals, we can say that 0.72n
Mm-hmm.
is equal to, take the 4 to that side, then we take minus 1 plus 13.8. 0.72n equals 14.8.
Minus 1 plus 13?
Sorry, 12.8, yeah. N equals 12.8 over 0.72, which is
2. And if you were really stuck, you could do 1280 over 72. But I believe it's calculator. So 12.8 over 0.72. Huh, that's weird. 17.7 recurring. Did we go wrong somewhere? The nth term of things that work the position of the term is value 2.36. Let's just check. 4.72 looks good. 2.36 times 5 is probably wrong. as 11.8.
Okay.
And so then it would be 10.8 on the top. Sorry. Yeah, 10.8 on the top. There you go. Yeah. Any questions there?
No, that's good. Well done.
Okay. So 11. That's 10. Okay. Oh, sorry. Part 2.
Show that 1 is not a term in the sequence. If we assume that it is, so we'll say 4n minus 1 over 2n minus 5 is 1. We can assume. So 4n minus 1 is 2n minus 5. 2n is is minus 4. So n is minus 2.
How does that show it?
You can't have a negative.
Yeah.
Yeah.
Yeah, no negative terms. So we reject it. Okay. So prove the limiting sequence. I think you'll be okay with that. Prove the limiting sequence. I think you'll be okay. So key points. Quadratic equations can be solved like that. Simultaneous equations. Okay. Linear inequalities. If you multiply or divide by a negative, you flip the sign. To solve a quadratic inequality, it helps to sketch the graph. Factor theorem, we went through. Index rules, we went through. Show all your working and approve. And then a linear sequence is an plus b, and a quadratic sequence, is an squared plus bn plus c. Okay, so that's algebra for further maths. X a half or tick?
I think that's a tick, yeah.
Okay, and so that's the first 4 chapters. So next is geometry, and it gets tough. Okay, I'll just jump into it. Try these.
Right, so this is the math geometry. So A and B is 125. The gradient so then change in y, the change in x is so you say that to be so 2 minus 5 over minus 4 minus 2 minus 3 over minus 6, which is a half.
Okay.
The gradient of the line perpendicular to AB. So a perpendicular line is the negative reciprocal. So that is just minus 2.
Yeah.
Length of AB. So you could use this as a kind of Pythagoras theorem.
Yeah.
So if I make a right-angled triangle, that change in y would be three.
Yeah.
Change in x would be be 6.
Mm-hmm.
Then we'll say that 6 squared plus 3 squared is c squared. So c is just the root of 6 squared plus 3 squared, which is root 36 plus 9 is root of 45, which is 3 root 5, the same third one.
Okay, and last one.
Coordinates of the midpoint of AB. So we can say that AB. So you have 2. So you could say 5 minus 2 gives you 3. 3 divided by 2 gives you 1.5. 2 minus 4 is 6. 6 divided by 2 is 3. So we know we're going to add 1.5 and 3 to the A values. So that means that you have midpoint is minus 2.5 and then the comma 5.
I don't think so.
No, wait.
So the way you find the midpoint, it's like the average of the x's and the average of the y's, like the mean average. So it's basically just add the two numbers and half it.
Oh, right. Okay.
And so I'll write a formula.
And so you add them both, right? Okay. So what's that? 2 plus minus 4 is minus 2. Minus 2 over 2 is minus 1. 5 plus 2 is 7. 7 over 2 is 3.5. Okay. So the 2 and 4 are the x values. So we'll say that it could be minus 3. No.
So the two y coordinates are 2 and 5.
Yeah.
So 2 plus 5 and then half it.
Oh, right. Sorry. So you get 7.5. That's no 3.5.
Yeah, 7 over 2, 3.5. And then same with x's.
Yeah. So you have minus 1 for the x's.
Yeah, that's it. Minus 4 plus 2 is minus 2, and then half it, minus 1. Any questions there?
No, that's fine.
Okay, and like the mean average gives you the central number, and that's why that works. Okay, so things get trickier. Let's try this.
Here's the point AB, and Q is the point 3A, 5B. Find, yes, if I just draw these 2 points,
Okay.
P is across somewhere, like, and then Q is 3 lots of A values, it's, and then 5 lots of the B. So yeah, so it would be a kind of positive gradient like that. So Q is here. So A, B, 5B. Gradient of PQ. So you can say the change in Y over the change in X is 5B minus B over 3A minus A. That's 4B over 2A, which is 2B over A. the length of PQ. We'll again draw a kind of right angle triangle here. So that's changing y is 4.
If I just go back for a second,
Yeah.
what do you notice about the gradient for this one and what we put into the square root for Pythagoras?
It's 3 root 5.
So what did we initially put into the square root?
Root 45.
Even before then, what did we put into it?
45.
Now, what are the two numbers we put into the square root? What was the input?
Right, 3 squared plus 6 squared.
Okay, what was the gradient?
3 over 6. Okay, so you basically, you have 4b. So if I get the 4b and 2a.
Even simpler than 4b and 2a.
Right, so 5b minus b over 3a minus a.
That's less simple. You simplified 4b over 2a.
2b minus 2b over a, is it?
Yeah. So it's literally the change in y and the change in x. So the difference in the y's was 4b. The difference in the x's was 2a. Let's think about it. Yeah, that is, because you can use it in its even simplest form. It's basically for every change in a, it'll be that. Or can we? Maybe if we do that, we'll only find half the length of the line. Yeah, we better use 4b and 2a. I think you're right.
Yeah.
Yeah. Okay.
So 2a. So 4b is b change the root. Basically, it's a root of 4b squared plus 2a squared, which is 4 root b plus 2 root a. Oh no, no, that's not right. So it will be it will be actually be 2b plus a.
I don't think you can do that because it's got if it was times or divide you could, but it's plus or minus in the middle. So you have to just square these and just leave it.
Okay, so yeah, it would just be the root of
And so what is 4b squared?
uh, 2b.
4b squared?
The root of like 4b squared.
No, I don't think you can square root it.
Okay, so would it just be the root of? Would we just leave it as that, or?
Well, what is 4b squared?
Oh, right, in the brackets. Okay, so that would be root of 16b squared plus 4a squared.
Okay, and so I noticed that this can be factorized. What can we do there?
Yeah, so you could have 4 outside the bracket and then 4b plus a. 4b squared plus a squared.
And then this, I think you can slightly square root.
Yes, so that would be 2 root of in bracket 4b squared plus a squared.
Yeah. And so I don't think we had to simplify it, but we simplified the last one, which was with numbers. Yeah, so that's as much as we can simplify it. Okay. And next one.
Yeah, so the midpoint of PQ. So the y values 5b plus b is 6b. 6b divided by 2 is 3b. You have, what is it? So that's what. So 3a plus a is 4a. 4a divided by 2 is 2a. Coordinates would be 2a, 3b.
Yeah. Any questions about any part of that?
Right, I got that still.
Okay. Yeah. Okay. Let's take a look at this one. Okay, how do we do this?
2, 5, b, 6, 2. The angle ABC is 90. Find two possible values of b. So we draw a right angled triangle.
Okay.
Here. That's 1, 2. 1, 2. B. I don't know how I could start this.
So it says there are two possible values. So I've just done a little sketch. So something like that.
Yeah.
And the 3 points, let's say two possible values for B. Any two possible values? Alright, pick two values. A. So A, B, C are 3 points. So this is A. This is C. And then so B has to be the third point to make it a right angled triangle. Well, if this was a right angled triangle, what do you know? Any idea what you would know about if it was a right angled triangle?
You have Pythagoras' rule, so
Yeah.
you can kind of Basically, the value of b would just be the change in y. So the height of the you'd get the height and then minus the 2 from it. Yeah.
So what is the change in x then?
That would be 5.
So the change in x is 5.
Yeah.
And so basically, the change in x is 5. So what would be the square? How would this work?
Change in x is 5.
So imagine that it's kind of like this or something.
So the root of 5 squared.
So that's for the length of the line. What is the length of the line AC?
AC is 5. Yeah, just 5, I think.
And what side is that? A, B, or C?
Is that? Do you mean? It's like, is it C or?
Yeah, it's the hypotenuse.
Yeah.
Okay. So that's 5 squared.
All right. So then, root of something plus something gives us 5 squared.
Mm-hmm.
So what are those values? So b minus, is it b minus 2 squared as one of them in a bracket, and b minus 2 and 5, is it? Oh.
Okay, so if we use B, so basically the length of this line must provide this B. If this is 25, is there an easy way to get? No, that's probably not. Okay, let's call that B. So A to B, the length of A to B would be square root change in x for that one. So what is the change in x for A to B?
That would be 4.
So that's 4 squared plus, and then yeah, b minus 2 squared in a bracket. So what would you get there?
So the root of 16 plus b squared minus 4b plus 4 is 5 squared. So b squared minus 4b plus 20 is 5 if we root both sides. So we can factorize this.
B squared minus 4b plus 20. Before you do that, what would be BC?
BC, C is that. Is it 1?
BC, well, it'll be from B to C.
Oh, sorry, so b minus 2.
So change in x.
Oh, yeah, that's 1.
And then change in y.
B minus 2.
Okay, and then squared.
Yeah, b minus 2. So in a bracket squared, yeah.
So it should be 2 minus b.
Oh, right.
I don't think it'll make much difference. Okay. So what do you get?
Right, so BC is root of 1 squared plus 2 minus b squared, which is root of b squared.
Okay. I just thought of an easier way to do this. I think, yeah. So this will work, what we're doing. Okay, so sorry, the square root that we get, it's going to be b squared minus 4b plus 4, and then plus the 1 will be plus 5.
5, yeah.
And so basically that is BC.
Yeah.
And so if we do a squared plus b squared equals c squared, so AB could be A, BC could be B.
Yeah.
And so what happens when you square a square root?
Use you have the same number, the integer.
Cancels it out?
Oh right, yeah, sorry. So yeah, that's what I so
okay.
Is that b minus?
So it's a squared plus b squared. So the square of this square root plus the square of this square root.
Oh right, okay. So b squared minus 4b plus 5 plus b squared minus 4b plus 20.
Yeah. 25. And that's equal to c squared, which was 5 squared squared.
Which is 125.
Oh, hang on. Is it? Why am I saying that? It's just 5 squared, isn't it?
5 squared, yeah.
Yeah, sorry, it's not 5 squared squared. Yeah.
Okay, so 2b squared minus 8b plus 25 is equal to 25.
Mm-hmm.
So you could say 2b squared minus 8b plus 50 is 0. B squared minus 4b plus 25 is still 0. So 25 is 5 times 5. How do you get minus 4 from that? Do you use a quadratic formula for this, or?
So is it not just b squared minus 4b equals 0? Because the 25's cancelled out?
Oh yeah, sorry. So yeah, so you have b outside a bracket and then b minus 4, which is 0. So b is 0 or b is minus. B is 0 or b is 4.
That's it. And so that b up there could be 4, or this one down here could be down there. And that could be at 0. The line is up at 2, so it could be 2 above or 2 below, basically. I've thought of a much quicker way. Silly me. So we did it using Pythagoras. Another way to do it is using gradient. If they're at a 90-degree angle, then you could get basically m1 times m2 equals minus 1.
M1 times m2 is minus 1.
So you know that about perpendicular lines?
Yeah.
Yeah, so then you would just find the gradient of these two. Then you'd find the gradient of the second two. And then you would multiply them together and make it equal to minus 1 and solve that. It would just be quicker. I think much quicker.
Yeah.
Yeah, anyway, sorry about that. Any questions about that previous one?
No, that's fine, yeah.
Okay, and then they said sketch it. And you can sketch it. So it goes up to 4 and down to 0. Yeah. Let's see. So these are the practice questions. For each of the following pairs, calculate the gradient of the line that's perpendicular, the length of the line, and the coordinates of the midpoint. So I think you're okay for each of those. These are vertices of a triangle. How would you show that it's right angled?
You'd have to see that the change in x is actually perpendicular to the change in y.
So you could find the gradient of all three lines, and two of them will be perpendicular. And you can see in part 2, they've said by finding the lengths of the sides, and that's how we did the one we just did. So actually, okay, we weren't too bad for doing that. So let's find the gradients of the lines, and we'll use that method.
Okay, so A 0 5, B 1, C Okay, so the gradient of AB is y into x, which is -4 over -1, which is -4.
Which is what, sorry?
-4.
I think it's over 4, isn't it?
Is it over?
Change in x is 4.
Oh, sorry. So yeah, 1 minus 5 over 4 minus 0, which is -4 over 4. That is equal to -1. A, B, and then BC, and then CA. BC is change, which is B to C 1 minus 7 over 4 minus 2, which is -6 over 2, which is -3. CA, change in y over change in x, which is 2 minus 0, which is I think that's 1, right? So CA is 1.
Okay.
You could say that AB is a negative reciprocal of CA.
Yeah, and if I had to show it, I think I would say M1 times M2 equals -1.
Okay.
Yeah.
Yeah.
And so AB and AC are perpendicular, therefore it's a right angled triangle. And then just in general, how would you do part 2? How do you use Pythagoras to show it's a right angled triangle?
Find the length of the sides.
Yes.
Wait.
Find the length of all three sides, and then
you find the length. You construct a triangle and then kind of get those like lengths for the right side, and then just solve it like a normal.
So the length of AB. So which two sides did we say were? So AC. What do you know about a triangle if it has a right angle and the three sides?
There's three Well, it follows Pythagoras's.
Yeah.
Rule. Oh, right. Yeah. So squared. Right.
So basically, you would find the length of all three sides, and then you would square AB, square AC, and you should get the same as if you square BC.
Yes. Okay.
Where AB and AC were the two perpendicular sides, so the two sides between the right angle. Any questions there?
When you wrote find the length of all three sides, like you had the AB and the AC and the BC in like straight lines. What do they mean?
It means magnitude. In this case, it would mean the length.
Okay.
It's just a shorter way of writing it.
Yeah. Okay.
Like the three dots meaning, therefore. Okay, how would you show that this is a right-angled isosceles triangle?
I'll just write the question down. So A 3 6, B is 7 4, B is 1 2. They're the vertices of a triangle. So show that ABC is a right-angled isosceles triangle. So if you write, just draw the points. So I might draw a set of axes because
just in general, how would you do it?
You just draw A as 3 6, and then just go along a bit,
So in our previous one, we didn't draw anything, and we got it. In this one, we didn't draw anything. We actually did. We drew a little sketch, but we didn't need it. What if we didn't draw anything?
Okay, so that means that, right, so if we find AB.
So the length of AB?
Yeah, the length AB. So you could have those.
Okay, and so once you have that, what would you do?
You get the length. Sorry, so length of AB, length of BC, and length of CA.
Okay.
You have to find out that if one of them is the negative reciprocal of another.
That doesn't work with length. You're thinking of something else?
If it's an isosceles triangle, two of the sides will be the same length. So
correct. So two sides will be the same length. Show two sides are equal.
Yeah.
So that would show that it's isosceles. How would we then show that it's right angled?
One of the gradients will be the negative reciprocal of another. So to find the gradient...
Could you do it without finding gradients? We've already found the length of all three sides.
I can't really see how.
Length of all three sides, right angled triangle?
They must
How would you show it's a right angled triangle?
They all meet.
How would you show that this is a right angled triangle?
You mark the angle which is right angle.
How would you prove that it's right angled?
You basically do. Oh, right. You just do Pythagoras' thing. So
yeah.
Sorry. So that would be basically AB, BCC. Yeah. So CA squared should equal AB squared plus BC squared.
Yeah. I'm not exactly sure which one It would be so the two equal sides squared added together would be the same as the third side squared. And that's how you would do it. Yeah.
Yeah.
I'm just not sure if AC is the hypotenuse or if AB is the hypotenuse. Yeah. And so for the previous one, we could do it both ways. We could find the gradients and then use the fact that they're the negative, like that they multiply to give -1 to show that they're perpendicular and therefore a right angle triangle. And then we also showed, well, you can also use Pythagoras. For this one, we had to find the lengths of the three sides anyway to find the two that are equal. And so we might as well just do, well, let's square that one, add the two together, and you should get the same as if you squared the third one. And they're probably even square roots as well. Any questions there?
No, I think I got that.
Okay, so there's more questions. Find the perimeter. How would you find the perimeter of a triangle?
You find all three lengths and just add them up. So the length would basically be the gradients of A, B, B, C, and CA.
No. Length.
Oh, right. So Pythagoras again.
Yes, you use Pythagoras to get the length of a line segment. So Pythagoras for all three sides, and then add your three answers. So you might get something like that, and then you would have to add all three up. Using AB as the base, find the area. Okay, and then you'd have to do some stuff. I just want to see what these look like. Find the length of, then they go to four sides. Find the lengths of four sides. Midpoints. Yeah. Lots of stuff. Okay, let's do a quick recap. Okay, how do we find the limiting factor?
You basically, so for the limiting factor, it has to be, if n is going towards infinity, you do the arrow. You say that 1 over n is, tending towards 0.
Yeah.
So basically you say n is tending towards infinity, 1 over n is tending towards 0, and the other thing that's over n is also tending towards 0. So you write it out and include those zeros to replace the n values. So then you get your answer as 2 over third if it's like a proof.
That's it. So it'll always be a over n tends towards 0 as n tends towards infinity. You always do it by dividing top and bottom by n. The other ones I think you're quite good for. You make it equal to it and then you solve. That was algebra. And then geometry. Yeah, gradient, change in y, change in x. What do you know about two perpendicular gradients?
They're the negative reciprocal of each other.
And how can you prove that they're perpendicular?
If one of them is the negative reciprocal of the other, they're both.
What if someone doesn't understand negative reciprocal?
It should be at right angles.
You would have to multiply the two together and what would you get?
-1, sorry.
Yeah, that's the kind of proof method for it.
Okay.
And then how do you find the midpoint of a line segment?
You add the two x values and you add both the y values, and then you divide each, like the sum of x values you divide by 2, the sum of y values you divide by 2.
Yeah.
And your coordinates.
That's it. So then we did a pure algebra. Then we did this. So we found we used the Pythagoras method for solving this algebra type. So like find the length of AB, AC, BC, and then 1 squared plus other squared equals hypotenuse squared. And then the possibly easier method would be the gradient method, which is find the gradient of AB, AC, BC, and show that two of them multiply to make -1. How do you show that it's an isosceles triangle?
Basically, two of the lengths have to be the same.
Yeah, and how do you find the length of a line segment?
You do the Pythagoras theorem, and you just
yeah. So there's lots more to do, but it's similar but tricky. How did you find that, Stefan?
Quite difficult, but I think I got it.
Yeah.
Now the slides like maybe right now, so I can just quickly go over it again and make sure I understand it.
Okay. Next time you want to continue this geometry?
Yeah, we'll continue it.
Okay. Any questions from me in general?
For further maths, like when about do you think we'll kind of finish the syllabus?
Let me just check. So further maths. So we're now in chapter 5. And there's 9 chapters in total. So we're at about the halfway mark, I think.
Okay, that's good.
So yeah. Anything else?
Oh no, that's fine.
Okay. Well done, Stefan. You're doing great. And look forward to chatting again next week. And I'll email this now.
Thank you. Speak to you next week.
All right. Have a good week. Goodbye.